Hi, Josh. Let's continue solving these two problems in trigonometry. So number one, we want to show us something. You solved this in the previous video. You can check out the other video
The
with the
link is
same.
also in the description.
Okay, the link will be in this description. That will be part A and this will be part B. So given that 4x is greater than 270 but less than 360 degrees, and that cosine 4x is equal to 17/32. Find the values of cosine x, cosine 2x, and cosine 3x. Show us the resolution in the previous video.
So this is the straightforward solution. This is the first solution presented. So nothing is wrong here. But here I would like to emphasize something that I did not emphasize last video. 67.5 degrees is less than x, which is less than 90 degrees.
Meaning,
So it means that it is essentially it's obvious already, since x is greater than 67.5, it is in turn less than, it's in turn wait, I'll just put it here. It's in turn greater than 0, of course. So that just means that x is in quadrant 1.
quadrant 1, yes. And in quadrant 1,
Quadrant 1, yes.
what are the values of x and y?
No, I mean cosine.
Cosine, yes.
Cosine x is positive.
Or greater than?
Or
Mathematical?
or cosine x is greater than 0, yes.
Greater.
So actually, these two values.
These were green.
I will cancel anyway. Something like that. U2 and U4, they are not positive, of course, they're negative. So they cannot possibly be the values of cosine x, since cosine x is greater than 0.
We can eliminate that. Yes, meaning
now we have only two candidates without just
so this that part of the solution in the other video can be done away with.
Yes. So now we have only two candidates. Those candidates are square root of 15/4 and 1/4. In the previous video, we already disproved how square root of 15/4 could be cosine x, because none of its values are in the acceptable range. 67.5 degrees is less than x, which is less than 90 degrees. But u3 does have a value in it. So you use u, which is cosine x, is actually u3, which is 1/4. I'll just where's the shading? Yes, shading tool. Yes. So cosine x is equal to 1/4. Also, I already proved also in the previous video cosine 2x.
And do you want to show us anything more?
Yes. So you might have noticed if you watched the previous video, I did not put the method of finding 3x here, because I will show a different method of solving for 3x. So now we will employ an identity trick. Cos A minus B. Let's put it here. So can I already start A cos B
Okay.
As you might have guessed, the outcome of this is cos quantity A plus B plus cos quantity A minus B is equal to 2 cosine A cosine B, while the signs are cancelled. So in the previous video, I still had the hassle of finding sign and the sign of 2x and sine of x. That's rather tedious. So in here we simply eliminated that. So we can think of useful values of a and b. So a could be x or 2x, and then b could be yes, b could be x. So 2x, 3x, x, 1x. Sin 3x. Maybe what if we try using a is 3x? Maybe that will be better. So then cosine a plus b will be 4x. And then cosine a minus b will be 2x. Yes, we already know 4x is given and 2x we already know 2 is equal to 2 cosine 3x, one variable. We will be able to isolate it, and then cosine b is cosine x. We already know that too. Good. Okay, so substituting, we have, what is the value of 4x? 17 over 32. 17 over 32. And then 2x is 7 eighths. Negative 7 eighths. Is equal to 2 cos 3x. And then cosine x is what? 1/4. Times 1/4. We can cancel the 2 and 1/4 is 1/2. Maybe if we multiply this by 32. Mm-hmm. So, so to donate, and then this will become 16. Yes, okay. So here 32 times 17. I'll just integrate it. 32, 8. So 8, this one, 7 times 4 is 28. 32, yes, cancel. Is equal to 16 cos 3x. So 11 negative is equal to 16 cos 3x. And thus cosine 3x is equal to negative 11 over 16. Easily.
Nice. Nice.
Yes, nice. Okay.
And do you want to present another solution?
The rather shortcut solution.
You can take the page. Set out the question.
I will just make up free real estate. Okay, so we have cosines 4x, similar to the previous solution, but it's shorter. Cosine 4x is 17 over 32 is equal to 2 cos square 2x minus 1, and then 2x is equal to 1/17 over 32 plus 1 into 9. Square equal to plus minus 7 is and then 17 degrees.
Yes. So explain to us.
Cosine is positive.
Okay.
Okay, so here cosine is negative, so I forgot the ink color.
So 2x is
Cosine
quadrant
2x,
two.
yes,
So it's
negative. So negative 7/8 is actually negative. Plus minus 7/8 is actually negative 7. So, speed run. Dream speed run. What happened to the 8? One times 1 is equal to 160. So you probably know where this is going. This is plus minus 1/4. Here we prove that cosine of such x that is in quadrant 1 is positive. So this is positive.
So yes.
Positive 1/4. Yes. Using the technique, the thing we did here of adding cosine a plus b and cosine a minus b.
That's how you
And
get
doing
the
that, that's how we'll get the cos 3x. Actually, at this point, once you have a cosine x and 2x, there's really not much you can do. It's mostly the same technique. Okay,
so let's go to the
I think this is done.
yes. Let's go to the next problem.
So
Can you prove this number 2? Proves. Can you state the problem, Sarah?
Prove the identity sine to the fourth sine
Raised to the
sine
a to raised to the fourth power.
yes, sine a raised to the fourth power
Plus
plus cosine a raised to the fourth power is equal to 3/4 plus 1/4 quantity cosine 4x. So
I mean, you will present several solutions also for this
yes.
year.
So okay. So the first solution I will be sharing is usually we start with the left side when we're proving, but this time I'll start with the right side because it seems that there's really not much you can do with the sine to the fourth a and cosine to the fourth a unless you use reduction formulas. So I will use those reduction formulas in another solution. But here, the cosine 4x, there are many double angle formulas. So in turn, there are quadruple formulas. So this will be easier to do. So I will start with RHS equals 3/4 plus 1/4 cos 4x. Then equals 3/4 plus 1/4.
4x.
Yes.
You should.
What? Yes. 2 cos square 2a minus 1. And then the 2a, we can equals 3/4 plus 1/4. We can just distribute the 1/4 for the moment. So the 3/4 can be handled. 2 cos 2a squared. This will cancel. Oh, it did not change color. Oops. Two. So 3/4 minus 1/4. Wait, I meant minus. 3/4 minus 1/4 is equal to 2/4, which is 1/2. 1/2 plus 1/2 cos squared 2a. Okay, so maybe we can put this sort of under one roof, but this time all of them will go under one floor. Mhm. Over, I mean, for arrow. Mm, Two. Mhm. Cosine 2a. Wait, or I do not. Cosine 2a is good. What if I just simplify first? 1/2 plus 1/2 cos 2a squared 1/2 plus 1/2. We will use the cosine and sine because we want to achieve both sine and cosine on the left hand side. The appropriate formula for cos 2a will be cos squared a minus sine squared a. And then this will be squared. So I will just expand 1/2 plus 1/2 cosine 4 to the fourth a minus 2 sine squared a cos squared a plus sine to the fourth a. I'll just go on the next page. So, continue. Oops, right click. So, where are we? Isolate this term. One half plus 1/2. I will just put instead of writing 1/2, put it put it over the 2. So, sine to the fourth a. I meant, why would I don't have, I have a pointer there. So, sine, and it disappeared. So, sine to the fourth a, then cosine to the fourth a, that's what we're looking for. So, we will isolate it. I hope it will lead somewhere. Sine to the fourth a. Oops. Nah. Plus cosine to the fourth a. And then the other one, the other term, 2 sine squared a cosine squared a, 2 times 1/2 is obviously 1, so we will put it outside. Is this plus or is it minus? Squared. It's minus. Yes, minus. Okay. So it seems like we have all what we need, but it's still locked. So this where we need some enlightenment. So instead of because many will they will just use since they see the sine squared a and cosine squared a, they will just expand the one into sine squared a plus cosine squared a. But here the sine to the fourth a plus cosine to the fourth a is under a 2, so we need another of it to complete the sine to the fourth a plus cosine to the fourth a. We need another of this fraction. So to get how do we get another sine to the fourth a plus cosine to the fourth a? We need another squaring. So 1 squared plus sine that plus fourth a plus cos to the fourth a. 2 minus sine squared a cos squared a. So the 1 we will expand into sine squared a plus cosine squared a squared. So just import this. Maybe actually I think it makes more sense if we just integrate this sine squared root. I already saw the path. It will, I think it will merge back anyway. Put here, oops. Why I really think that we don't need to move it out because anyway, I think we will need it again inside.
How did it become like you converted the one to
Here,
mm,
I just realized if we bring it out and then we'll bring it back in, probably there's no sense in bring it out anyway. So I don't have enough space. It's getting rather long, but we just have to endure this. It's going to get rather short. Okay, so as I was expecting, this will yield the sine to the fourth. Yes, this will yield sine to the fourth a, and then there's plus 2 sine squared cos squared, sine squared cos squared. I wish they would just invent such a notation. E plus cos fourth a 2, and then plus this humongous other fraction. You probably see where this is going now because those are over 2 over 2. So we can now cancel these. This plus and this minus. See, I told you we will need to bring it back in anyway because otherwise we'll have to bring this out. So that's an unnecessary step. That's an unnecessary step anyway. So this is sine to the first a because see the light at the end of the tunnel. Ah, same word. Okay. Over 2 plus yes. So as earlier I was talking about how we would need some squaring, and apparently we did need some squaring because the sine to the fourth a plus cosine to the fourth a was not complete yet. But now it is complete. So in fact this is it. This is LHS. Okay, it's the first solution. It's the
Because this one will become, can you put here below? Just what-
but
How did you cancel the two for those who are trying to learn?
this one. We can undistribute the sign away. This is one.
Yes, or it can also be like this. It can also be two sine is to the fourth sine a is to the fourth power plus cosine a is to the fourth power over two. And then finally, so we accelerate. So and there will be one times this one plus this one. Okay, so do you have any alternate solutions?
Yes. So one is like earlier. Uh Now we can
Is it the reduction or expansion?
I wrong color. Once again we will use the RHS first. We I'll just copy the problem. This LHS.
Left hand side, your issues.
The lag. Maybe it's too high. Yes.
Question mark. Three-fourths plus one-fourth cosine for x.
4. Yes. Okay. So LH is equals to maybe I will just start already. I will just it will be redundant. The fourth the over 4 divided by 4. We will wait. I'll just bring this down.
Shows
Yes.
steps.
The divided by 4. We can integrate. 3 plus cosine 4a. So the cosine 4a squared 2a minus 1. So wait. Let's put the intermediate. This is equal to cos 2a. I think earlier we did this too, maybe. I'm not sure. Anyway. 2 wait, we will substitute this into the cos 4a, 2 cos 2a minus 1.
Okay, this clear solution.
Yes. So we will just every single step equal to 2 times 2 cos. If you notice, I'm using the purely cosine uh identity for cosine 2x, because in this case the we only need cosine. We don't really have any sine yet. So this will simplify. I will just put the -1. So the oops. So the constants are together. Yes. And then I will substitute this for, just put a pointer again. Hopefully this time it will work. So I will just ooh, it's not working. So I will substitute this into 2 cosine squared 2a. So it's untraceable. Oops, only a. Then all over 4. And then now it will be straightforward. 2, 3 minus 1, 2, and then this one will be I forgot something. This needs a square. This will also have a square. Yes, side and time. So I was about to proceed. Expands. So this is 4 4 in or this 4. I think I'm running out of space. I'll receive the next page. So font. This is what? This is 2. Yes. Expand. I mean distribute. So
Distribute.
so 8. What's the minus? What's that the minus? Yes. Minus cos squared plus 2. So of course I will combine the twos. They're both constants. This will equal 4 plus 8 cos 4a. I could have factored the 2 earlier, but who cares? I will just factor it out now. This is equal to 1 minus maybe I'll just put in ascending order. I'll just arrange in ascending order. It looks much better, either in descending or ascending. Whatever's the standard, especially in your country. In some countries, it's the other way around. Uh, and then so from here, this will be a pro move. 1 minus 2 cos squared A plus cosine. Notice what I am separating in y. So I separate this from the other cosine for A because this is a perfect square. And then this is 1 minus cosine squared A squared. So cosine 4A, which is equal to sine squared A squared plus cosine 4A, the fourth A, is equal to sine to the fourth A plus cosine to the fourth A, which is LHS. So again, RHS is equal to LHS. Yes, nice. So one last solution for this. This is the earlier I was talking about. Where was it? Earlier I was talking about how we went from RHS because RHS is we know double angle formulas, but there are other formulas. Those are a little more complex formulas that have not really more complex, but formulas that have a much more complex derivation. Those are the power reduction formulas. So we could use them on sine fourth A and cosine to the fourth A. So we will be able to finally use LHS like a traditional solver. So I'll just turn on the increase the light. Okay, there. So here
Is the third
this is
solution
the
for
third
the
solution.
problem.
This is the reduction one.
I think you're going like, ooh, nice solutions. Nice. See the you do the way I was saying I'm saying it. Nice.
The
Okay,
British
joining
unit.
your math enthusiast, or you just want to learn. These solutions are really very nice. If you're able to come up with another solution to prove this identity, you can share it with us. Send a link in the comments.
It's getting quite long. Zoom. I captured the look at the poor equal sign. I captured it. Oh, no, yes, I've spared them. The tiny little. Okay, so maybe okay, so I'll do this first.
The fourth power is the fourth power.
It will be overwhelming if I also reduce sine to the fourth A. So I'll just separate it from now for now. I'll just use these marks because they will the sine to the fourth A will appear continuously. So there's no reason in continuously writing it. 1 plus 2. This will be a direct hit into LHS to RHS.
See, this will also be Nice solution.
Rather based. So cosine square 2a. Uh, cosine square 2a without remark, a small remark. 2 cos square 2a minus 1 is equal to cos 4a. So we can find cos square 2a minus 1 in terms of to the fourth a. Cos to the fourth a minus what? Plus 1 over 2. Then oh wait, so forgot equals. I keep forgetting the equals. Equals hmm,
Oh, yeah, yes.
the power of the undo function. If you haven't used the undo function, then why haven't? Why haven't you? I'll just once again separate the 1/2. So because the constants are annoying, they garble up the solution when I don't need the constants. I can just separate them anyway. So I'll just separate them now. 3/2. Because anyway, I will later merge the constants if I don't merge them now.
Fine.
Mm. So we sine force A plus 3a plus 2 plus y. Yes. Yes. So we will continue the next page. I will use up too much space. Mommy, we are here. Mm. We are here. We are here. Oops.
Box. Continue range.
Moment. Wait. Okay, so now, earlier I preserved the sign for A because it will be overwhelming. Now I will, actually we could have done that earlier, but it will be too hard. Maybe it will be prone to errors.
Silent for power.
So we need a few more steps now.
A big and nice solution.
Similar to earlier, I will express the
Put that away. So
seen anyway.
my face will be seen.
Imagine.
Nice.
Mm-hmm. Mm-hmm. I will be writing it. I will just repeat writing it anyway, so there's no reason in doing it. If you don't have to do it, just don't do it. Equal sign. Rather do.
Loss. Loss.
1/2 1/4.
So just looking for lines at the end of the tile.
Yes, don't you see it? It's already here. It has arrived. Here's the delivery of the solution. So we've arrived at the end of the tunnel now. I forgot. Okay, so
Nice.
similar to earlier, cancel, cancel. And then now this will be 3, 4, 5, over 4, which is equal to 3 fourths plus 3. Oh, I got so used to using RHS. This is actually RHS. So this is LHS to RHS.
Yes.
Yep.
Very nice. Hope you
Yes. So I hope
like
you
that. You will keep this, so you taking in the video. So those who are watching, hope you like the solutions of Joshua for these two problems. This and the additional solution for number one and the three solutions for number two, which is proving this again. Thanks for watching.
thanks for watching.
Thanks for watching my amazing sign.
Bye.
Bye.